Hello and good morning. This is Mehek Arora and welcome to the third and last session of the chapter Acid, Bases and Salt. Before we go on to discussing whatever we would be studying in this chapter, it would mostly be theory. Let's recall what we studied in our previous sessions. Let's begin. We studied that only strong bases are bases that are capable of reacting with metals to produce some kind of salt and evolve hydrogen gas. So the general equation would be metal reacts with a very strong base to give you salt and hydrogen gas. The most common one being sodium hydroxide reacting with zinc to produce a salt called sodium zincate and evolving hydrogen gas. The formula for sodium zincate is Na2ZnO2. Bases react with non-metallic oxides in a similar manner how acids react with metallic oxides and they produce salt and water. The example that we studied was calcium hydroxide reacting with carbon dioxide to give you a white precipitate of calcium carbonate and water. Now, if you pass CO2 gas for a longer period of time in slake lime, then this calcium carbonate will dissolve in water because calcium hydrogen carbonate will be formed. And calcium hydrogen carbonate CaHCO3 is what is soluble in water, while calcium carbonate, which is CaCO3, is not soluble in water and hence forms a white precipitate. We know that acids and bases are able to conduct electricity because acids and bases can dissociate into their respective ions in an aqueous solution only. While compounds like glucose and alcohol, though containing OH molecules and H atoms or molecules, cannot dissociate into their respective ions in an aqueous solution. Acids release H plus ions and bases release OH minus ions. The movement of these ions is what helps electricity flow, current flow through them and produce electricity. So this is why acids can be termed as acids. They can produce H plus ions and hence they are acids. Bases can produce OH minus ions and hence they are called bases, substances which produce OH or release OH minus ions. We know that acid must be slowly added to water drop by drop and not the other way around, because both adding water to acid and adding acid to water are exothermic processes. It means a lot of heat is evolved during these processes or chemical change. So we must always take care while mixing any kind of concentrated acid with water. Acid must always be slowly added to water. If the opposite is done, then the mixture may cause the container that is holding the acid to splash out and it cause burns due to excessive local heating. Always look for warning signs when differentiating between dilute acids and concentrated acids or any other kind of chemical substances. That is all that we studied in the previous session. In this session, we would be studying about the strength of acid, bases and salts, what is actually the pH and what is pH values of acid, bases and salts, what is a pH scale, importance of the pH value in our everyday life and why is it important to maintain and keep that pH value to the point where it is there. We will study a lot of family of salts including common salt, baking soda, bleaching powder, plaster of Paris. Mostly this session is all theoretical and not much of explanation, so I will go through the whole theory with you and tell you what all is important and what all must be kept in mind. Then we would make a summary of whatever we studied in this session, and after that we will recall the entire chapter acid, bases and salt and recall what equations are important to know. So without any further ado, let us now begin this session. Strength of an acid or a base. You know that acids release H plus ions in their aqueous solution and bases release OH minus in their aqueous solutions. Now, if a lot of H plus ions can be released by a particular acid in an aqueous solution, then the stronger that acid would be. If more number of OH minus ions can be released by a particular base in an aqueous solution, then the stronger that base would be. So strength of an acid depends on the number of H plus or OH minus ions that are produced by an acid or a base in an aqueous solution. Larger the number of H plus ions produced by an acid, the stronger that acid would be in aqueous solution. Larger the number of OH minus ions that are produced by a base in an aqueous solution, the stronger that base would be. Now, higher the hydronium H3O plus ion concentration in the solution, lower the pH value. So all bases will have low pH values, all acids have low pH values, and all bases have high pH values, and all salts or neutral substances come in between. So acids will have pH values ranging from 0 to 7, neutral substances will have around 7 or below 7 or maybe above 7, depending on whether strong acid weak base, strong base weak acid concentration is there. And then alkaline substances, bases that dissolve in water are called alkaline. Alkaline substances will have a pH of around more than 7 to 14. So the range of pH goes from 0 to 14. Higher the hydronium ion concentration in a solution, lower the pH value. So we know that acids release H plus ions, they go combine with water to form hydronium ions. So acids have high concentration of hydronium ions, and hence acids have low pH values, or acids are indicated by low pH values. So pH means power of hydrogen ions. So pH is basically a figure. It's a figure that expresses either the acidity or the alkalinity for bases, because bases that dissolve in water are called alkaline substances. On a logarithmic scale, that is why the scale that you see in front of you is in 10 raised to power of something, and that power of something is what determines an acid's acidity or alkalinity of alkalis or bases. So on a logarithmic scale, we actually express acidity or neutrality or alkalinity of acids, bases, or salts. So on a scale of 7 is neutral, lower values are more acid, they are not exactly acids, we say they are more acidic in nature. Higher the pH values, we say they are more alkaline substances. So in chemistry, pH is a scale that is used to specify acidity or basicity of an aqueous solution. Lower pH values will correspond to more acidic nature of a substance. Higher pH values will correspond to substances which are more basic or which are more alkaline in nature, and salts will correspond to neutral substances. And at room temperature, pure water is neutral and has a pH of 7. Now, acidic substances can go from 0 to 7. Basic substances can go from 7 to 14. Neutral lies in between these two. They go from about 5 to 9. The color that you see, reddish to going to a bit orange yellowish, is what is representing lowering in acidity or lower in hydrogen ion concentration. Then higher as the color goes darker, from greenish to bluish to darkish blue to purplish, we see lower hydrogen ion concentration, more of hydroxyl ion concentration or OH minus ion concentration, and more basicity. Greenish colors, that is from 5 to 9, represent neutrality of substances. This is the pH scale. This pH scale specifies how acidic a solution is and how basic a solution is, or how neutral that solution is. pH is a figure that specifies or expresses the acidity. Scale is what shows the acidity. Now, Acid or bases, basicity or acidity of acids or bases depends on the concentration of H3O plus hydronium ions or OH minus ions by bases that are produced in the solution. So if you take hydrochloric acid and acetic acid of the same concentration, they produce different concentration of hydrogen ions. So that is why we are able to differ which is a stronger acid and which is a weaker acid. When you dissolve hydrochloric acid, or when you have an aqueous solution of hydrochloric acid, they are able to produce more hydronium ions as compared to acetic acid. Acetic acid is an organic acid, it's a weak acid. It cannot produce as much as H plus ions as hydrochloric acid or sulfuric acid can do. That's why these acids are termed as stronger acids, while acids like organic acids like acetic acid or formic acids, they are termed as weak acids. So the higher the amount of hydrogen ion or hydronium ion concentration in an aqueous solution, stronger the acid. So acids that give off more H3O plus ions are said to be strong acids, while those that give fewer H3O plus ions are said to be weaker acids. Same with bases. The more OH minus ions these bases can give in an aqueous solution, the more basic those substances will be, the lesser OH minus ions they would be able to give out in an aqueous solution, the more weaker these bases will be. Neutral substances will not give off either H3O plus ions nor OH minus ions, they remain neutral. So neutral substances, either perfect neutral substance has a pH value of 7. Now, what is the importance of the pH value in everyday life? Why do we classify an acidic character of a substance or a basic character of a substance to be more acidic than the other, to be more basic than the other? And why do we have the pH scale that measures these acidic values? Plants and animals. Plants and animals, they are pH sensitive. Living organisms such as us, we can only survive in a narrow range of pH change. Means we need neutral conditions to survive. We cannot survive in a completely acidic environment with pH 0, 1, 2, or completely basic environment with pHs of 13 or 14. So when pH water of rain is less than 5.6, it is less than 7, so it is acidic in nature. Now when it goes to more towards the acidic side, it means it becomes lesser than some threshold value, then that rain is called acid rain, and it is not favorable even for plants, for animals. It will mix in the river water and it will cause damage to aquatic plants and animals. And it will also lower the pH of river water, which is at a neutral state. So the survival of aquatic life or aquatic plant life or aquatic animal life will also become difficult. So plants and animals, we need some kind of neutral conditions or a neutral range to survive in. If the pH of that condition is either lowered or either is risen high, the conditions become difficult to survive. And the pH and such acidic rain will also cause harm to the soil or to the crops, because they need water to survive, and water is neutral in nature. Next, pH is what causes tooth decay. You know that tooth decay starts as soon as the conditions in our mouth, they turn acidic. When our mouth is not rinsed in a proper manner, or when leftover food is there, saliva in our mouth is acidic in nature, which acts on it. It breaks down the food that is left in our mouth and stuck to our teeth, and hence it rinses it off our mouth. But tooth decay will start when the pH of this mouth goes lower than 5.5. Tooth enamel, that is our teeth, it is made up of a substance or a compound called calcium phosphate, CaPO4. It is the hardest substance in the body. It will not dissolve in water, but it is capable of being corroded by acidic substances. So whenever the pH of mouth is going below 5.5, then bacteria that is in the mouth, they produce a lot of acids. These acids actually what help you degrade the food that is present in your mouth, but they will also start acting on the tooth enamel. The best way to prevent this is to use toothpastes, and toothpastes are basically basic in nature, and they neutralize the acids that are present in our mouth or near the teeth area, and they prevent tooth decay. So maintaining a certain neutral pH range even in our mouths is important. Next, we know that HCl is present in our digestive system, and whatever food we intake is broken down into smaller part by the action of hydrochloric acid that is present in our stomach. So we know that stomach has some acidic, it is acidic, so its pH value is lower. Its pH value is lower, but it also needs to maintain a range. It cannot exactly go down to 0, 1, 2. That then it will start to corrode the inner linings of our stomach, and that would be harmful. So our stomach produces hydrochloric acid, and it helps in digestion of food actually without harming the stomach. During indigestion, what happens is the stomach produces a lot of acid. This acid actually lowers the pH of your stomach, and it causes a lot of pain and irritation. To get rid of this pain and irritation, you actually use something called antacids. Antacids reduce or neutralize the excessive acid. They do not neutralize the entire acid, but the excessive acid that is produced by your stomach. Milk of magnesia, which is magnesium hydroxide, which is a mild base, it helps you often by reducing the excessive amount of hydrochloric acid that is present in your body, and it is often used as an antacid. Antacids are substances that act opposite to acids by neutralizing them. Now, what the pH of our digestive system is around 7.3, and it needs to be maintained in that range. If it goes below that or if it goes above that, it causes problems. Now, pH of the soil. Even plants that survive or that are grown in the soil, they require a specific pH range for their growth. And to find out the pH that is required for a healthy growth, you can collect samples and then test them. But you have to see that even plants for healthy growth, and especially crops that grow and that are fodder for us human beings and us and animals and other mammals, it is important for us to have plants or consume plants that have a certain neutral pH range. We cannot consume acidic substances, and we cannot consume a lot of basic substances. That is why the environment or the conditions in which plants or crops grow in, it needs to be in a neutral range. It cannot be an exact value, it needs to be in a neutral range. So we see that pH is very important in our day-to-day life, since we need measurement and ranges in which plants, animals, our daily life survival can take place. Now, pH of salts. We know that when acids and bases react with each other, we get salt and water. So now we have to see that when a stronger acid reacts with a weaker base, the pH would be towards the acidic side. It means that the pH won't be exactly 7, since the hydrogen ion concentration would be more than the OH minus ion concentration. The neutralization will not be perfect. So the pH value of that salt will be towards the acidic side. It will be less than 7. Then salts of weak acid plus strong base, they will have more OH minus ion concentration than the hydrogen ion concentration, and hence these will be towards the basic side. These salts will be towards the basic side. They will have more basic character, and hence they will have pH values of greater than 7. So the salts that we would be studying in this session are common salt, plaster of Paris, washing soda, bleaching powder, and baking soda. We will study the chemical formulae of these salts. We will study how they are produced and what are their uses. I will go through them with you one by one. Let us begin by common salt. Sodium chloride or NaCl is what is used as common salt. You know, one of the most important ingredients in our food is that common salt. Deposits of this solid salt are found in several parts of the world, and these deposits are large crystals. Often they are mixed with a lot of impurities, and a whole process goes through into making this rock salt be distinguished into common salt. So, this common salt is an important raw material for various materials of daily use such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Sodium chloride that we have, that is NaCl, common salt, can be used to produce sodium hydroxide, chlorine, and hydrogen gas by a process called chloroalkali process. So when electricity is passed through an aqueous solution of sodium chloride is called brine. It decomposes to form sodium hydroxide, and this process is called chloroalkali process. This process must be remembered. And other products that are formed with sodium hydroxide are chlorine and hydrogen. We will not go into detail of how that process takes place. We only know that the dissociation of sodium chloride in aqueous solution leads to formation of Cl2 gas at anode, hydrogen gas at the cathode, and sodium hydroxide is formed near the cathode of these three products. And all these three products that are formed are very useful. At cathode you get chlorine that is used, at anode you get chlorine that is used for water treatment. It is used, you know that swimming pool water is cleaned with chlorine. It is used in making PVC pipes and pesticides. Hydrogen gas is given at cathode, which can be used as a fuel. It can be used, it is used in ammonia for fertilizers. Both hydrogen and chlorine that are given off at different cathodes can be mixed together to form hydrochloric acid, which is used for cleaning. It is used as a chemistry agent, and it's used in medicine. Hydrochloric acid is used to make cosmetics. Then sodium hydroxide that is given actually is used as a degreasing metal. It is used in soaps, it is used in detergents, it is used in paper making. Sodium hydroxide is also used as a chemical to make artificial fibers. So sodium chloride itself can be dissociated through passing electricity to it. This process is called chloroalkali process. Chloroalkali, why? Chloro for chlorine, alkali for the base, that is sodium hydroxide. And it produces a lot of important other substances that can be used for various other purposes that we just discussed. Let us now go to the next salt, bleaching powder. Bleaching powder actually has a formula of CaOCl2. The actual formula is way more complex, out of our syllabus, so we won't be studying it. Bleaching powder is produced by production of or action of chlorine on dry slaked lime. Dry slaked lime has a formula of CaOH twice, that is calcium hydroxide. Bleaching powder in its simplest form is represented by the formula CaOCl2. So when calcium hydroxide reacts with Cl2, we get CaOCl2 plus some water. So one molecule of calcium hydroxide, dry slaked lime, reacts with one molecule of chlorine gas, and the product that you get is CaOCl2, bleaching powder, plus H2O. Bleaching powder is a whitish soft powder. It is used for bleaching cotton and linen in the textile industry. It is used for bleaching wood pulp in paper industry. It is used for also bleaching washed clothes in the laundry industry. Bleaching powder acts as a heavy oxidizing agent, and it is used in a lot of chemical industries. Bleaching powder can be used to disinfect drinking water by removing a lot of bacteria and making it free of germs. And bleaching powder can also be used in the preparation of chloroform. That is all for bleaching powder. Let us go to the next salt that we would be discussing. It is sodium hydrogen carbonate, NaHCO3, baking soda. Chemical name of the compound baking soda is sodium hydrogen carbonate, represented by the formula NaHCO3. When NaCl reacts with water, carbon dioxide and ammonia, you get NH4Cl, which is ammonium chloride, plus you get NaHCO3, which is baking soda. Now, this NaHCO3 is a base and it is a mild non-corrosive base, means you can store it in various metals and it would not exactly react with them to form a layer over that metal, that is the corrosive plate. It won't do that. It's a mild non-corrosive base. So when you heat this baking soda, what you get is sodium carbonate plus carbon dioxide and water. This sodium carbonate is what is washing soda, that we will be discussing next. Now, the chemical formula for baking soda is NaHCO3. NaHCO3 can be used in a variety of cooking substances, and you know that baking soda is one of the important ingredients in a lot of bakery industry. Baking powder also mainly contains NaHCO3 or baking soda, and NaHCO3 produces CO2 on heating and sodium carbonate, and this bubbling goes into cake or bread. This is what helps the cake and bread to become more smoother and more fluffier. Sodium hydrogen carbonate is also an ingredient in antacids. Why? Because it's a mild non-corrosive base. Base can neutralize acids, hence NaHCO3 is an important antacid. Being alkaline, it means alkali are some bases that are soluble in water. Being alkaline, it neutralizes excess acid in the stomach and it provides relief. One more base that we know of that usually acts as an antacid is magnesium hydroxide. It is also called milk of magnesia. NaHCO3 or baking soda is also used as one of the components that will act as one of the main components in fire extinguishers. Baking soda is also used to treat wounds as it can act as an antiseptic. Next salt that we would be studying is washing soda or sodium carbonate. When you heat NaHCO3, then the components that you now get is sodium carbonate, water and carbon dioxide. So Na2CO3.10H2O is the actual chemical formula of washing soda. So sodium carbonate with 10 molecules of water is what forms washing soda. So this 10H2O, that is representing the whole chemical formula for washing soda along with sodium carbonate, is called water of crystallization. So when you rehydrate sodium carbonate with 10 molecules of water, the formula that you thus get under certain conditions is Na2CO3.10H2O. This 10H2O is water of crystallization, and this entire formula, hydrated sodium carbonate, is what is washing soda. Sodium carbonate and sodium hydrogen carbonate both are very useful chemicals in industrial processes. Mostly washing soda is used as a detergent. It is used in making glass, soap and paper industries, and a lot of sodium compounds can thus be made out of sodium carbonate, such as borax. Borax is again a compound which has a very complicated chemical formula, and it also contains a lot of water of crystallization molecules. Sodium carbonate can be used to make a cleaning agent for domestic purposes, mostly detergents, and permanent hardness of water can also be removed using washing soda. Hardness of water comes when substances like calcium or magnesium are mixed with water. This makes water harder, and washing soda or Na2CO3 is something that can help remove that hardness of water. That is it for uses of washing soda. All these salts that we have discussed, their formation and their uses and their chemical formula is something that you must always keep in mind, and how one can be formed from the other. Now, what is water of crystallization? As I already told you, fixed number of water molecules that are present in one formula unit of salt. For example, Na2CO3, sodium carbonate is one formula unit of the salt sodium carbonate. Some fixed amount of water molecules are attached to that salt, and those fixed amount of water molecules are called water of crystallization. So the chemical formula of washing soda is Na2CO3.10H2O. It is sodium carbonate decahydrate. Deca stands for 10, and you can conclude that it contains 10 water molecules of crystallizations, or 10 water of crystallization molecules. Same way, we have a salt called copper sulfate, and copper sulfate, usually hydrated copper sulfate, has 5 molecules water molecules of crystallization attached to it, and that makes the chemical formula for hydrated copper sulfate as CuSO4.5H2O. Another salt that we would be discussing, that is the last salt we would be discussing, that possesses water of crystallization, it's called gypsum. It has 2 water molecules in the crystals in one formula unit, and it is represented by the formula calcium sulfate.2H2O. So it is important to know sodium carbonate has 10 water of crystallization molecules in its formula, copper sulfate has 5, gypsum has 2. Now let us go to plaster of Paris, which is calcium sulfate and half a molecule of water of crystallization. If you heat gypsum at around 373 degree Kelvin, it loses the water molecules partially to become calcium sulfate hemihydrate, that is CaSO4 half H2O. This calcium sulfate hemihydrate is what is called plaster of Paris. This is the substance which doctors use as a plaster for supporting fractured bones in the right position. Plaster of Paris is also a white powder, and on mixing with water it sets into a hard solid mass due to the formation of gypsum. So plaster of Paris is what is used mixed with water to form gypsum, which forms a hard coating around any substance that it is used. Now you must be thinking how half a molecule of water can exist. Actually, 2 molecules of CaSO4 share 1 molecule of water. So to write it in the form of 1 molecule of calcium sulfate, we divide the water molecule and just represent it as half a molecule of water. It does not really exist as half a molecule of water. So plaster of Paris, that is CaSO4.half H2O plus 1.5 H2O, gives you calcium plus calcium sulfate and 2 molecules of water of crystallization, and the entire chemical formula is termed as gypsum. Plaster of Paris can be used to make a lot of toys, materials for decoration, and even can be used to make a lot of surfaces smoother. This is all for the family of salts that we would be studying in this session and this chapter. All the chemical formulae with their common names must be remembered, and the equation, balanced equation of how they are formed, and with 2 to 3 uses of each. Now, this is it for this session. Let us recall what we studied in this entire session. We started by studying that the strength of acids and bases depend on the number of H plus and OH minus ions that are produced in an aqueous solution. The more the number of H plus ions that are produced by an acid, the stronger the acid would be. The more the number of OH minus ions are produced by a base, the more stronger that base would be. In chemistry, pH is a scale that is used to specify the acidity or basicity of an aqueous solution. Lower pH values will indicate that the solutions are more acidic compared to the other, and higher pH values will correspond to more basic or alkaline solutions, and neutral ranges will specify for salts or other neutral substances. At room temperature, pure water is neutral and has a pH of 7. We know that plants and animals, we require a certain neutral pH range for survival, and we are pH sensitive. We know that decrease in the pH of our mouth will cause tooth decay. Calcium phosphate that our tooth enamel is made of will start to corrode itself. We know that digestive system will have to maintain a pH of around 7.3, and when excess of acid is produced by our stomach, we need to take antacids that will nullify or neutralize the excess acid that are produced by our stomach. Plants will require a specific pH range for their healthy growth, especially crops, and that is how pH is important in our everyday life. Salts are produced by reactions of acids and bases. We know that salts of strong acids with a strong base and are neutral with a pH value of 7. Salts of strong acid with weak base will be more acidic in character, will have pH values that will be a bit less than 7. Salts of weak acid plus strong base will be a bit basic, and towards the basic side, pH value will be greater than 7. Common salt or NaCl is an important raw material that is used for variety of raw materials, and it is used to produce sodium hydroxide, baking soda, washing soda, bleaching powder, and many other substances. Mostly through a process called chloroalkali process, an aqueous solution of NaCl, when electricity is passed through it, you get chlorine, hydrogen gas, and sodium hydroxide as end products. Bleaching powder has a simplified formula of CaOCl2. It is produced by the action of chlorine on dry slaked lime and has the chemical reaction CaOH twice gives plus chlorine will give you CaOCl2 plus H2O. It is used for disinfecting drinking water. It is also used as an oxidizing agent. Baking soda, chemical name of the compound is sodium hydrogen carbonate or NaHCO3. It is prepared when sodium chloride, water, carbon dioxide and ammonia react together to give you ammonium chloride and sodium hydrogen carbonate. This is how baking soda is produced. Baking soda is a mild non-corrosive base, and it can be used as an ingredient in the baking industry as the most important use. Now, Na2CO3, washing soda with sodium carbonate with 10 molecules of water of crystallization. It is used in glass, soap and paper industries. It is used in the manufacture of sodium compounds such as borax. Water of crystallization is the fixed number of water molecules that is present in one formula unit of a salt. Now, plaster of Paris has a chemical formula of calcium sulfate dot half H2O, that is CaSO4 dot half H2O. This is called plaster of Paris. It is a substance that doctors use to plaster when you have to support fractured bones in an accurate or a right position. CaSO4 dot half H2O plus 1.5 molecule of water will again form CaSO4 dot 2 H2O, that is the chemical formula for gypsum. That is all for the salts that we studied in this session, and that is all for the entire session that we studied. Now let us recall what we studied in the entire chapter, acid, bases and salt. We know acid is a substance that is capable of releasing H plus ions in an aqueous solution. Acid is a substance which tastes sour, it turns blue litmus red, and it neutralizes bases. Bases, on the other hand, release OH minus ions in their aqueous solution. They taste bitter, they turn red litmus blue, and they neutralize acids. Salt is a neutral substance whose aqueous solution does not affect litmus. We know acids react with metals to produce metal salt and hydrogen gas. Like HCl,